Stress-free learning with
Inonyam.
create a better tomorrow. You with the program. Hard work pays off, so come and put it in. No need to wait, let the lessons begin.
No matter how you feel, get up, dress up, show up, and never give up. Okay, boom. Okay, we're about to get started. Today, what are we doing? We're doing limits and average gradients. Okay, so limits. What are limits? Limits are, it's when a value of a function, or when a value, limits is a value that a function approaches as a variable of a function approaches or tends to a certain number, right? So what am I talking about? This is what I'm talking about. And let me write it visually so that you can see what I'm talking about. So limit as x approaches b of g of x, right? So how do you say this? You say the limit of x, the limit of g of x as x approaches b. So how do you say it again? The limit of g of x as x approaches a point b. B could be any point. It could be 2, it could be 4, it could be any number that is approaching, right? So since we have that now, let's do an example so that we can get the idea of what I'm talking about, right? So example 1 under limits. What does it say? It says limit as h approaches 0 of 10h plus 5h squared divided by h. Right? Normally, what you could do is you could just substitute the value of h inside, right? Because that's the whole point of a limit. So you want to be able to substitute the value of h inside there to see what the limit is. But at the point right now, if I substitute 0, what happens? There's an undefined because h at the bottom, there's an h at the bottom. If I substitute 0 into h, it becomes whatever is at the top in the numerator over 0, which is undefined, as we all know, right? We do all know that, right? Okay, anyways, so let's move on. So now what do we do once we're stuck with that conundrum, right? It's a pretty good word. I've said it a couple of times. So now let's move on, right? So now I have to continue to write the word limit as h approaches 0 until I have substituted what h is equal to 0, right? So what's the first thing? Limit as h approaches 0, right? What can I do to factorize what's at the top? Well, I can take out a common h. There's an h on both sides, plus 5h divided by h, right? That's what I have now. What do you see now? Do you see something that makes sense to you? Because if you see something right now, what is it? It's a matter of, I can cross out something. What is it that I can cross out? I can cross out my h's. The h at the bottom and the h at the top. The h at the bottom was giving me problems, but I now just got rid of it. So since that's done with, so again, I still haven't substituted h. So I still write limits as h approaches 0 of 10 plus 5h, right? Let me put it in bracket so that it doesn't confuse you, right? So this is what I have now. Now let me ask you, can I substitute h without having problems? Of course I can. There is no denominator of h. The denominator over here is 1. So if I substitute what h is, which is 0, I will have 10 plus 5 times 0, right? So my final answer will be equal to 10. Because 5 times 0 is 0. So this is basically what limits are all about. And if you're going to universities to do engineering, you're going to be seeing a lot of that nonsense. So yeah, that's it. So now let's look at average gradients, because this is basically the end of limits. We'll look back on this in other chapters, right? So average gradient. I'll write it on the side here. Average gradient. It's the gradient of a straight line. It's a gradient between 2 points of a curve, right? So since it's the average gradient, it's just a straight line that joins those 2 points. So what's the formula that you already know of gradients? The formula you have is m is equal to y2 minus y1 divided by x2 minus x1, But you already have, you can use this one here, or you can flip it around. You can say y1 minus y2 divided by x1 minus x2. As long as you start with the same y value, in the same point on the y value and the same point of the x value, right? So that's my formula. That's basically what I'm going to be using to calculate average gradients. Stop procrastinating. Stop putting things off until later. Do them now. You got homework, do it now. You got a test that you have to do it now. Do practice for it, study for it right now. Not later, not on the weekend, not when I finish this, when I do that. Do it now. And this could be one of your test questions. And imagine that. That's a simple formula. How can you go wrong with that one? Okay, so let's look at an example. Example 1 under average gradient, right? Right? So my question says, for example 1, calculate the average gradient of g of x equals to x squared plus 3x plus 2 between the points a, 10 and ya, and b, negative 2 and yb, right? So what's my first step? Let me write my formula down, right? If you have a formula, you should always write it down first before starting anything. Just write it down and then you figure out what you have and what you don't have. So that's my formula, right? So do I know what y is? No, I do not. I do not know what y is. Do I know what y is for a or b? No, I don't know any of those two y values. Do I know the x values? Yes, I do. Okay, so where can we go from here? I have two unknowns, right? Am I stuck? Is this a bad question? Is this a hard question? You might be saying yes. If you're saying yes, it's a hard question, you need to work harder, because this is the easiest question you could get in your paper. It really is. So what do? I look at the points, right? So I look at my points that say is equal to y2. Okay, y2, I'm going to assume that this b is y2 and this a is y1, right? So I'm going to say, what is y2? What is y on that side? Y is equal to b. It's yb minus ya divided by, what is ya? What is my x value on 2? It's negative 2, right? And what is my x value on this? It's 10. So it will be negative 2 minus 10. So I have this. Again, I have two unknowns. I still don't know what to do, right? So what do? What do I know about this? What do I have? I have the function g of x. Calculate the average gradient of g of x between those points. What is that telling you? It's telling you that you are given the graph. If you are given the graph, you can plug in those points and you get your y value. So I'm going to rewrite this. I'm going to write this as g of negative 2. I'm going to write it as g of negative 2 minus g of 10, right? Because those are the 2 points those are the 2 x points for those 2 different positions. So over here for position 2, the x coordinate that I could use is negative 2, and for this point the x coordinate I could use is positive 10. Why do I put it into the equation? Because g of x is the same as saying y. Y is equal to x squared plus 3x plus 2, right? So now I have g of negative 2 and minus g of 10. So what do I need to do? Over negative 2 minus 10, right? I need to find what g of negative 2 is and g of 10 is. So g of negative 2, if I plug in negative 2 into this equation, what do I get? I get 0. So g of 10, if I plug in 10 into that equation, what do I get? I get 132, right? So those are my 2 y values. So let me write them again as is equal to y a is equal to yb and is equal to ya, right? So now I have those two values. What does it mean? I have all my values. Let me plug them in and see what the result is. So this is equal to g of negative 2 is equal to 0 minus g of 10, 132, divided by negative 2 minus 10, right? What is that equal to? So I can just add. This is simple math now. Just put it in your calculator if you're not aware yet. But you can say negative 132 divided by negative 12, which is equal to positive 11 because the negatives will cancel out. So my answer will be equal to 11, right? So the average gradient between these 2 points is 11, which is your final answer. And you have gained yourself 2, 3, 4 free marks, really. There is not much work in that. You didn't work for that. That was for free. They gave it to you. So yeah, that's limits and average gradient. Okay, boom.